Hi everyone, now we're going to move on to the second lesson of our unit. It's called Pythagorean Theorem. I'm sure, well at least I'm hoping that you've come across this previously in maybe your junior high math courses, and it is a skill that we will use throughout the rest of this unit. And it's a general good skill as you move into the workforce. Various types of job careers, trades will rely on using, well, various measurement skills with triangles. Before we get started, just a few things we want to go over here. Please remember that a triangle that contains a 90-degree angle is always called a right triangle or right angle triangle. And remember that it's always kind of communicated to you with this square pattern right here. So if I were to draw another one, as long as this occurs, you can see that you have a right angle triangle. Okay, and that's going to be, remember, 90 degrees. The second part here is to remember that the hypotenuse is always going to be across or opposite from the 90-degree angle. Okay? That always is going to happen. So if I were to draw another one, just to make sure that we recall this, if I go like that, that's my 90-degree angle. Remember, we're thinking of it as kind of an arrow, and it's always pointing towards the hypotenuse. So that kind of takes care of that. No big deal there. The next fact here is to remember, or well, I hope you remember this, that the hypotenuse is always going to be the longest side on any right-angled triangle. So if you were to by chance, let's say I'll just go up here to this triangle. This can never happen. You couldn't have, let's say, this be 8 centimeters and your hypotenuse be 6 centimeters. And in fact, if you work this out, if you were to use Pythagorean Theorem or some trigonometry later on, you actually would get an error right now. But just so you know, that cannot happen. Your hypotenuse must be the longest side in any triangle. Now, this is the basic Pythagorean Theorem formula. C squared equals A squared plus B squared. And you may find it to be a very simplistic formula. I've also seen a lot of people have difficulties with this, and I'm going to try to break this down for you. So what I'm going to say is I want to maybe go ahead just a little bit. I know that on the next page here they show you these 3 formulas, but I might try to go down to 2 and help you really understand this better. If we call, let's say, type 1. Type 1 is when we use Pythagorean theorem to find a missing side in a triangle, and that missing side is the hypotenuse. So type 1 is when you want to find the hypotenuse. Okay? And that means that you have been given 2 out of the 3 sides of a triangle, and the one that you are missing is the hypotenuse. If that is the case, this is the formula that you want to use, and it is going to be the C squared equals A squared plus B squared. Now what you might be thinking is, well, what if the letters of the triangle change? Well, let's try to get away from that. How about, let's think of this as a little bit different. If we go C squared equals A squared plus B squared, think to yourself that if you're looking for the hypotenuse, it's out here by itself, and the other 2 sides are added together and squared. Now, if you're kind of thinking, well, what the heck are you talking about? So if I erase this here, I'm going to show you how this works out. So let's pretend that I am given A, let's say this side is 5, and I am given B, and this side is 4. And you're thinking to yourself, okay, find side C. Well, you have to think to yourself, okay, I am missing the hypotenuse in this case. Therefore, the formula looks like this. C squared equals A squared plus B squared. This is the formula you're going to use when you are missing the hypotenuse. The other thing you're going to notice here then is that C squared stays vacant. You have nothing to put there. And you have A and B, and it looks like this. You would go A, so you have 5, and you have to square it, plus 4, and you have to square it. If you take this a step further to continue the pattern, that would give you c squared equals, you have to go 5 squared. And that's not 10, that's 25. Plus 4 squared, it's not 8, it actually is 16. And if I just shoot over here for a second, c squared, what I'm going to do now is I'm going to add these two values together because that's the only operation that we have left in this question. And what that's going to give you is 41. Now, side C is not 41. That's really big compared to 5 and 4. What you must do now is square root both sides. So you would get C equals, and square root is kind of this check mark looking thing. Hopefully your teacher can help you find that. And if you square root 41, you're going to get an answer in the ballpark of 6.4. Now, what if we change this up? So what I'm going to do right now actually is I'm going to erase what I have here. And remember, you can watch this over as many times as you want. You can go back, you can see what I all did there. But one of the typical questions I'm often asked is, well, okay, you gave us Pythagorean theorem. It's c squared equals a squared plus b squared, but what if the sides are different? Like, let's go here, let's say that this is actually going to be x. And let's say that this is y. And let's say that this is z. Now what I'm going to tell you is that side x is going to be 6. And I'm going to tell you that side y is going to be 5. But what I want to ask you here again is you've been given two sides, and neither of them are the hypotenuse, and you've been asked to find side z. Therefore, remember, it is in this pattern where you have one side, the hypotenuse, is equal to the other two sides added together. So I guess if I was going to do the letters, this would give me z squared equals x squared plus y squared. This is the form you use when you're looking for the hypotenuse, because we've taken this side and this side, we add them together. So you're going to get z squared equals 6 squared plus 5 squared. Z squared equals 6 squared is 36. 5 squared is 25. Z squared. You add those two together now, and you're going to get 61. Now that missing z is not 61. You have to square root that. That gives you a z value equal to, you have to square root 61, of about 7.81. Now I really want to focus on something again. When you are looking for the hypotenuse is going to be by itself, and you're going to add the other two sides together. This is the only form of this formula where you have something by itself and the other two sides added. Heck, if the letters were like this, you might have e squared plus f squared. You're going to use that formula when you are looking for the hypotenuse. But if we go forward, well, what happens if you already have the hypotenuse? So if I skip forward just a little bit here, okay, at the top, if you look at example 2 here on this page, very clearly you can tell, you can find your 90-degree angle, and you can say, oh my goodness, we already have the hypotenuse. Therefore, this equation is no longer valid, because when we have c squared equals a squared plus b squared, that is the form we use when we are looking for the hypotenuse. So what I'm going to do, to try to make this as the least amount confusing as possible, I would like you from now on to use this formula. I want you to go b squared equals c squared minus a squared. So what the heck am I talking about? When you have a triangle and you're given two sides and you know the hypotenuse, I want you to use this formula. And here's what you're going to do. The missing side, no matter what you do, we're going to call that b. So that's going to be b squared. C squared is always the hypotenuse. You're going to go 12.8 squared. Take away, well, let's see. If that's b and this is c and that's got to be a, 10.78 squared. And then if I just kind of go to right here, I'm running out of room, 12.8 squared would give you 163.84, and